17 is an example we need to discuss. So limit as x approaches negative, or similar examples. 3t squared, so this is t. 3t squared plus t over t cubed minus 4t plus 1. Okay. So let me stop sharing. So we are asked to find this limit. What do we have to do first when we are asked to find limits?
Look at the highest powers.
Yes, so the answer is plug it in. This function does not have a natural log, which has a restricted domain, does not have a square root, does not have absolute value. So the first thing we need to do is plug it in. So your answer is perfect. Because we are plugging in into a polynomial and we are plugging in negative infinity, yes, the answer is correct. We have to look at the degree. So my question is, at infinity or negative infinity, doesn't matter, which of these two terms is the most powerful one?
T cubed for the bottom.
Between these two terms, at t approaches infinity.
3t squared.
Excellent, excellent, perfect. So now imagine that you plug in negative infinity in t squared and tell me where is that numerator going? What is the tendency of the numerator?
Infinity.
Infinity indeed. Infinity indeed. Good. Now let's do the same thing to the denominator. From these three terms at infinity, because if you want me to plug in 0, all three terms are important. But when we want to talk about infinity or negative infinity, only one term is important. Which one? Because it's the most powerful.
T cubed.
Perfect. So imagine that you plug in negative infinity in t cubed and tell me what you get.
Negative infinity.
Excellent. The first indeterminate case that we discussed was 0 over 0. This is the second indeterminate case, infinity over infinity. The sign is not important. So these are the first two indeterminate cases. That we've seen so far. There are 5 more to look at later. Okay, so knowing that it's infinity over infinity, there is hope. So all these indeterminate cases have hope. I'm not saying that the limit exists. I'm only saying that there is hope. It's possible. Good. So here's how we continue. I will not do my circle and jump. I have to write it again. So limit as t approaches negative infinity. So here, let me copy it. You don't have to copy it if you didn't copy this. Okay, so you already told me that the degree at the top is how much? 2. Degree is 2. I will factor out t squared. The degree at the bottom, I don't care what the numerator has. The degree at the bottom is?
3.
Good. I have to factor out t to the third. And now here's a little discussion before we continue. You could say, and I will have to say that you are correct, you cannot factor out t squared here. It's not a common factor. I have to agree. It's not. But look at this example. If I have x to the 4th plus 3x to the 3rd, can I factor out x to the 10th? Yes. As long as x to the 10 times this will give me x to the 4th, and x to the 10th times this will give me 3x to the 3rd, I can factor out anything I want from anything. Because now x to the 10th times 1 over x to the 6th is x to the 4th, and x to the 10th times 3 over x to the 7th is 3x cubed. So if you say you cannot, then I'll say yes, I would agree t squared is not a common factor, but I can factor out anything I want from anything I want. As long as these two terms, and here respectively 3 terms, when I distribute t cubed, I get this, I'm allowed to do it. So can anyone give us the two terms here?
3 plus 1 over t.
3 plus 1 over t, brilliant. Can anyone give us those three terms in here?
1 minus 4 over t squared plus 1 over t cubed.
Brilliant. Thank you very much. At this point, of course, I'm going to simplify 2 t's from the top and 2 t's from the denominator. And I still have one left. Now, I'm allowed to, so please remember, I have the limit operator because I did not apply it. I have the limit operator because I did not apply it. The limit operator is here because I did not apply it yet. Now I am ready to apply the limit operator, and it will disappear because I'm applying it in the very last step. Can anyone tell us where this is going when t approaches negative infinity? And before you answer, let me refresh your memory. As long as this is positive. So where is 1 over t going as t approaches negative infinity?
0.
Thank you. Where is 4 over negative t squared going when t approaches negative infinity?
0.
Thank you. Where is 1 over t to the third going when t approaches negative infinity?
0 again.
Thank you very much. So what is left? I don't want to touch that. So what is left from the top?
3.
What is left from the denominator?
1.
Excellent, stay with me. But there is another t in the denominator. So I have 3 at the top and t in the denominator. So what is the final answer?
Over t.
Say it again.
Is it 3 over t?
So the limit,
0.
exactly. So the limit of 3 over t as t approaches infinity or negative infinity is 0, which means y equals 0 is a horizontal asymptote. Since it's a pure rational function, it will be at both sides, not just at negative infinity.
I have a question.
Please.
So it doesn't matter if it's like there's no way to note if it's approaching 0 from like the positive side or the negative side. It's just 0 either way.
Careful. T approaches negative infinity. Very good question. We're not on the left or right side of 0. We are so far away that we cannot even see each other. T approaches the end of the world. T does not approach 0, so I can plug in 0 from the left and 0 from the right.
No, I meant from like, I guess it doesn't matter from like the top and the bottom. Like
Ah.
those, but I guess that doesn't matter.
It does, but we cannot determine that before we graph the function. Very good question. Brilliant. So you can ask here, okay, y equals 1 is the horizontal asymptote. Why did you come from above? Could you have come from below? Yes. So I don't know. So the limit will not tell me. Very good question. So I will not know till I graph the function whether it's coming from above or it's coming from below. But it's approaching 1. Yes, we care. When we get to graph these functions step by step, of course we will care. But we have other ways of determining that, whether it holds water or it does not hold water. But we have to get to chapter 4. We have a long way till then. Brilliant question. Hold on to your question. We will clarify that in chapter 4. Thank you. Very good. Awesome. I see what you meant. Very good question. Good. So now let's continue with other examples. Allow me to use or choose another here, very important one like 25, and then you can choose. Let me see my time here. 10 minutes. Oh, that's good. Okay, so 25. As you see, there are so many different types of limits. So many different types of limits. Okay, so this is a totally different one. Then we have to look at one of these, and maybe one with the exponentials. And we kind of covered what we need. We'll see. Okay, so we're asked to find the limit of the square root of 1 plus 4x to the 6 over 2 minus x to the third. What do we need to do first?
Plug it in.
Yes, because we don't know the type of situation. Yes. So, under the square root, which of these two terms is the most powerful one? I know it's silly.
4x to the 6.
Yes. So, plug in, as imagine that you plug it in, take the square root, and tell me what you get.
2x to the third.
When x approaches infinity, plug it in and tell me what you get. I have to write a number here. I cannot write any x. A number or a symbol. Yes.
Infinity.
What about here?
Negative infinity?
Of course, of course. So, see, these were the two indeterminate cases. This was one. We started with infinity over negative infinity. Who would have thought that we're going to get 0? No one. Well, if you remember from pre-calculus, you will say, oh, I know. Smaller degree in the numerator, higher degree in the denominator. As x approaches infinity, the answer has to be 0. I agree. But without looking at the function, if you see infinity over negative infinity, or the sign is not important, you would not know what to expect. Same thing here. We hope that the limit exists. We'll
The
see.
minus sign, the subtraction, doesn't affect it at all.
So one more time. As x approaches infinity,
Oh, it's positive, sorry.
it doesn't matter which of these two terms counts at infinity.
Just the x cubed.
Exactly. Exactly. Perfect. Good. And no, don't say rationalize. No, we cannot rationalize something like this. That's not the issue here. We don't have two terms and use the conjugate. No. Similarly with the previous situation, we will have to factor out. Let's start with the easy one. What is the degree of the denominator?
3.
Yes. So I have to factor out x cubed. And please tell me what is left.
2 over x cubed
Yes?
minus 1.
Perfect. Now, I know the book shows you to multiply the top and bottom. Please don't. I accept it. It's a silly method. But I have to accept it. It's in the book. But don't. You will see why in a minute. Now, let's look at the square root. Can anyone tell us the degree of the polynomial inside the square root?
6.
The degree. What is the degree of this polynomial? Maybe you said it and I didn't hear it.
I thought I said 6, but maybe I
Oh, I didn't hear it. Good. I'm sorry. Forgive me. That's what I said. Maybe you said it and I didn't hear it. Can anyone give us the binomial inside?
One
And,
over
1 over x to the 6th. Yes, plus?
4.
Excellent. Good. Stay with me. So now this is the limit as x approaches infinity. I'll copy the denominator. And now I copy the square root, but with a 1 over x to the 6th plus 4, because remember the property, the square root of a times b is the square root of a times the square root of b if both are real only. Okay? Otherwise, the property doesn't work. So can anyone give us the square root of x to the 6th? So let's discuss the square root of x to the 6th. So we can put it in front. And the correct answer is not x cubed, but the correct answer is
Do you just take one power off?
so
X
what?
to the 4.
Okay, so let's refresh our memory. We divide 6 by 2, and I said it's not x to the 3rd, but what is the correct answer? This is a discussion we had last time. Brilliant question. Can anyone tell us the answer of the square root of... Yes?
The absolute value.
Brilliant.
Of x cubed.
Please always remember that. It's the absolute value of x to the 3rd, which will be x to the 3rd if x to the 3rd is positive, or negative x to the 3rd if x is less than 0. This will tell us which one it is. Which one is it? What do I put in front?
Positive.
Yes, because x approaches infinity. What would you have written if we had x approaches negative infinity? If we had that situation, what would you have replaced this by?
Negative x?
Yes. Yes. So that's why that method that shows the book is showing us with multiply this and this, you will have difficulties understanding what the sign is. So please don't do it. Of course, this is the whole thing. That's all I wanted. And now, can anyone tell us where this is going when x approaches infinity? Anyone? We had this situation like 3 or 4 times before. 4 times.
Zero.
Good. Where is this going when x approaches infinity?
Zero.
Good. Where is the numerator going as x approaches infinity?
4.
Careful.
2.
Yes. Where is the denominator going as x approaches infinity?
-1.
Good. And the limit is?
-2.
Negative 2.
Good. Because this is not a pure rational function, we can only say that y equals -2 horizontal asymptote at infinity only. Awesome. Any questions? Any questions?
You mind going over how you got 2 over -1 again? I kind of got
0
lost.
plus 4 is 4. The square root of 4 is 2. 0 minus 1 is -1. 2 over -1 is -2.
Can you go over why you
Wait. Just one second, Casey. Is this okay?
Yeah, it's fine.
Okay, perfect. Casey?
Can you go over why you chose x cubed is greater than 0 rather than x is less than 0?
It's so far from negative infinity, from negative numbers. Look at where it's going.
All right, thank you.
Is that clear?
Yes.
Excellent. Other questions? But if I had x approaches negative infinity, I had to use this, not this, because this is where negative infinity is, and this is where, oh, of course it's the same, but I have to write x cubed first. So when x approaches negative infinity, I have to use the negative infinity. So I have to use negative x cubed. Okay, I want to look at 2 more. So let's look at 32. In 32, we have limit x minus the square root of x as x approaches infinity. Okay, we're asked to determine this limit.